Hey, I'm Travis. For 3 months, I was in the Florida Everglades and Florida Keys helping out with various research projects focusing on wading birds and their prey. I was just an intern at Florida Atlantic University, but the knowledge and skills I gained helped me fully appreciate this unique ecosystem. I'll be your guide on the current state of the Everglades, what's being done about it, and what I and several others were doing on a daily basis to help learn more about this complex ecosystem. First, a quick bit of background on the Everglades. Historically in the Everglades, water flowed south into Lake Okeechobee, filling it during the wet season. Water then flowed from the lake south through the Everglades. However, humans interrupted the natural flow in order to make more dry land, resulting in a flow that looks more like this. By 1947, much of the Everglades was drained. As a result, 68% of plant and animal species became threatened or endangered, important fish species declined, and wading bird nesting activity dropped by 90%. By 1950, the damage had been done, and people began fighting for restoration ever since. In 1999, the Comprehensive Everglades Restoration Plan, or CERP, was proposed to restore the natural flow of the Everglades. The plan is to use the best scientific research to restore the right quantity, quality, timing, and distribution of water back to the Everglades. Currently, some areas receive too much water due to the flow being restricted, as evident here just north of the Tamiami Trail, and some receive far too little, evident here, south of the Tamiami Trail. When the 30-year CERP plan is completed, the vegetation should return, the fish should return, and the wading birds should return. Which brings us to the first of several research projects that I'll explore with you. The Dry Season Prey Concentration, or the Fauna Project, in the Florida Everglades. Typically, the Everglades follows a wet and dry season. The dry season is what triggers wading birds to start nesting in the Everglades. During the dry down, large amounts of fish and other prey are concentrated into small pools. The ability of the birds to catch its prey skyrockets, giving the birds plenty of food to feed their young. Current water levels in parts of the Everglades don't allow for a typical wet and dry season. Since its construction in 1928, the Tamiami Trail has been one of the biggest culprits of this. South of the trail will often dry faster and completely, whereas north of the trail may stay inundated with too much water, causing prey to be more spread out and harder for birds to catch. One major project is currently working on building a series of bridges to elevate the road and help restore a more historic flow to the Everglades. Still, optimal water levels need to be determined for year-round conditions in order to come as close as possible to the historic flow as well as the wet and dry seasons. That's what the Fauna Project is trying to determine for CERP. Models are being made to determine the optimal water levels for each season as well as each different area of the Everglades. Data is currently being collected for these models, which is what I and several others were helping with. And yes, we are just taking off from some random parking lot. To collect the data, several 500 square meter plots are randomly selected in different areas of the Everglades. The random plots are reached via helicopter, due to many of the sites being too far apart or inaccessible by airboats. Among these plots, an area with optimal water levels for bird foraging is needed. Therefore, a bit of recon is done and water depths are collected. When optimal water levels are found, usually in a slough, throw trapping points are randomly selected. Throw trapping is an important part in collecting data for prey density, prey abundance, prey biodiversity, and water levels in the slough. Once the trap is thrown, water depth is recorded at each quadrant of the 1 square meter trap to get an average water depth of the slough. Then, for each quadrant, the closest to the center submergent vegetation as well as emergent vegetation is recorded. This is done to serve as a sort of vegetation survey for the slough itself. Then, all the vegetation is ripped out, so it doesn't get in the way of seining, of course. All caught prey is collected and placed in a jar with MS-222, a humane chemical for killing fish. Seining is done until there are 5 swipes in a row with 0 prey catch. The topography and water depths of the area around the randomly selected throw trapping point is also recorded via transects on either side of the throw trap. All this information will help build a model for CERP. This particular throw trapping was actually done at Lake Okeechobee, but it still serves the same purpose for the explanation. Unfortunately, I don't have much footage of us working on the Fauna project. It's often very difficult to both film and work. Once all plots are done and data is collected for the day, we unpack our gear from the helicopter, and it takes off to, more often than not, help out with other research projects happening in the Everglades. The Everglades isn't the only area with declining wading bird populations. Let's go just off the coast of Big Pine Key for the Little Blue Heron project. The little blue heron. Smaller when compared to some other wading birds, their shorter leg length restricts their foraging to certain water levels. With rising sea levels, this makes them one of the first wading birds to potentially be affected by climate change. Therefore, a habitat suitability model for foraging is being developed by Marisa and Emily. Population numbers and nesting locations of little blues are typically unknown. Because of their small size and dark color, the birds in their colonies are much harder to locate, and to film as well. So Marisa and Emily are also searching for nesting colonies. We begin early in the nesting season here, just north of the Big Pine Key. An early morning start ensures that we're able to catch the low tide, when it's optimal foraging habitat for wading birds. Finding where little blues are foraging can also help us key in on where they might be nesting. First thing is to observe the little blues foraging success rate for Marisa's thesis project. After anchoring the boat in the shallows during low tide, we must kayak to get an even closer look at the little blues. Yeah, I didn't fit in my kayak too well.
I'm way too big for this thing.
What?
Nothing!
But the birds must be within 200 meters to properly observe them foraging, so off we go. Once within range, we begin our observation. Done in pairs, once a foraging little blue is located, a 10-minute observation is started. This study focuses on foraging intensity and success rate. To measure this, we count the number of steps and strikes an individual takes, aka foraging intensity, and whether or not prey is caught during the strike, aka success rate. To do this, one person records data while the other observes, counts steps, calls out strikes, and successful strikes.
Strike. Oh, he's got something.
As time goes on and the 10 minutes is up, the little blues move out of range and we must travel in closer. The low tide makes it difficult to kayak, so we must wade instead. Tiring, yet beautifully isolated. Although the seagrass and soil itself is soft, it's full of rocks, which get stuck in these stupid Keen sandals. Oh, they're the worst. There's a whole ecosystem stuck in there. God.
Terrible.
Once we arrive closer, we begin observing and recording again. And we cover up from the sun, because we don't want our faces to look like leather handbags by the time we're 40. There are actually several hundred birds here of different species that we're viewing, but unfortunately GoPros are awful at picking up anything that's not less than 5 feet away. You'll just have to imagine the beautiful sight of all the foraging birds, and of the lemon and nurse sharks that surround us as they forage on the low tide as well. But until tomorrow. next day, it's time to throw trap in the areas we observed the little blues foraging the day before. We set up at low tide, roughly 200 meters from the desired location. It can be very difficult walking through some areas of the seagrass. The mud is very deep at times, so we get inventive on how to carry things. Yeah, that didn't work. Once the first random throw trapping point is chosen, we're ready to go. Just like in the Fauna project, throw trapping is important to figure out prey density, prey abundance, and to see what kind of prey is available that the little blues might be catching.
That's good.
This data, when compared to the foraging intensity survey from the day before, will give us a better idea of what habitats are most suitable for little blues. What we catch is diverse, and often surprising.
Sorry.
Crustaceans like this pistol shrimp are not affected by the MS-222 as well as fish are, and must be pithed before collected. Faster and more humane than suffering in a jar. When we're done with all the throw trapping points, we can look for nesting little blues on one of the many mangrove islands, which are strange yet fascinating. Searching is simple. Look and listen. So those are cormorants that we hear. Got about 2 hours on this island. If they were here, it would have been pretty obvious by now. But it gives me the chance to explore. It's pretty cool in here. And to be a bit artistic. Keens suck. All they do is get rocks in your shoe. Horrible. So there's no little blues, but there's a lot of cormorant nests. There's one right above me. I'm gonna see if I can get a closer look at it. Yeah, there's just cormorants all over. Not much else. Still cool. Alright, we'll meet back up with Marisa and Emily later in the season. Much further up north, some wading bird colonies of different species have already been found, and are nesting. This is the Colonies Project. Another problem facing the Everglades is the astounding number of introduced or exotic species of both plants and animals due to humans accidentally or purposefully releasing them through various means. Nearly 1,400 non-native plant species and 500 exotic animal species have been observed in Florida. Around 26% of all reptiles, birds, mammals, and fish in South Florida are exotic. A kind of joking rule of thumb is that if you found it in Florida, it's probably not from here. Because human activity and exotic species have been changing the Everglades ecosystem for over a century, Ashley, a master's student, is setting out to see how well 3 similar species of wading birds are adapting to their altered environment. More specifically, she is seeing which birds are learning to utilize and forage in the man-made canals that litter the urbanized areas of South Florida. Since there's a higher proportion of exotic prey in the canals versus the Everglades, comparing the birds' consumption of exotic and native prey items is an excellent way to determine which species are adapting their foraging behavior to use the canals. This prey consumption is then compared to nesting success of the wading birds. It's predicted that nesting success will be higher in birds that have more exotic prey in their diet, thus showing that they are more capable of adapting to an altered environment. To test this, we're at the Protus colony in the Everglades. As you can tell by the noise, there's plenty of nesting birds to find here. As we enter into the colony, we look for nests belonging to one of the 3 target species. Not these ones. These are great egret chicks. Not these ones either. These are roseate spoonbill chicks. Climbing trees to access a nest is a regular occurrence. And it's not easy doing it in waders covered in mud. Whew, that was fun. Here we go. Here's some tricolored heron chicks. When a new nest is located, we flag it and record the number of chicks. When a flag nest from a previous week is found, then the number of surviving chicks is recorded and compared to prior weeks. Chicks are then taken from the nest to collect a bolus sample. A bolus is basically just what the bird throws up. They often regurgitate when a predator is threatening them to supply an easy snack for the predator. Then, hopefully the chick is left alone. When not readily regurgitating, a chick can be enticed to do so with an upside-down undulation motion. When the chick regurgitates, the bolus is collected and provides the vital data of how much native and non-native prey the birds are selecting. Unfortunately, I was unable to film a chick supplying a bolus sample. As I mentioned before, filming and working at the same time is difficult, so you'll have to settle for some bile instead. You know, I don't think I ever washed my hands before I ate my sandwich that day. After the bolus sample is collected, the chick's keel is checked for fat levels and the chick is placed back into the nest. Bait fish is then fed to the chicks to resupply them with food. Ashley's project isn't without its own searching, though. In order to collect a large amount of data to support her thesis, she must visit many different colony sites throughout the Everglades, and some still need to be found. Here in Big Cypress, we're heading to where a colony was last year. The swamp itself is beautiful, and again gives me a chance to try and show you what beauty lies here. As we head in deeper, it becomes evident that the birds that nested here last year are not returning this year. However, the search will continue here as well. With an above-average rainfall this year, birds are nesting later in some areas of the Everglades, and not at all in others. Up in the littoral zone of Lake Okeechobee, wading birds here have been nesting for a few weeks now. This is I don't think this project had a nickname. Okay. This is the nesting wading bird colonies in the littoral zone of Lake Okeechobee project.
What?
Yeah. Lake Okeechobee, Florida's liquid heart. The wading bird colonies here are closely monitored as part of the Monitoring and Assessment Plan for CERP. The project monitors timing, size, and location of colonies in this highly managed lake. In the 1920s and 1940s, several hurricanes caused massive flooding, resulting in over 3,000 deaths. By the late 1960s, the Herbert Hoover Dike was constructed and completely encircled the lake. All water released from the lake is now completely managed via levees. Yeah, that's right. All the water that flows through the Everglades is managed by people. Seeing up close and personal on how large the lake, the dike, and all the Everglades are just blows my mind on how we're trying to completely manage an entire ecosystem that has been operating on its own for thousands of years. Also, another problem worth noting is all the agricultural land just south of the lake and north of all the Everglades. To say the least, agricultural runoff into the Everglades is also a problem. Well, let's get back to the wading birds. In order to understand the effects this highly managed lake has on wading bird populations, aerial surveys are done in the littoral zones of the lake to locate and determine the size of wading bird colonies. 3 of the largest colonies found are given transect routes to do on foot. Nest survival monitoring is then done along these routes by David and Jenna. We must first reach the colony via airboat. The vegetation gets surprisingly thick at times. Cattails tend to overrun areas due to agricultural phosphorus runoff. Walking in these colonies is a little tricky. Most of the time we are walking on a mat of floating peat, which feels a bit like walking on a giant waterbed, but deep holes in the peat can come out of nowhere.
Yeah, there's a hole there. Oh, that one's so deep. Can you get out of there? Oh, I guess so. Oh no, I went under a bit. Whew. Okay, there's a hole there where you're gonna go under. So how'd you choose this transect? Just wherever you could walk in, pretty much? Randomly chosen?
The transect route is indicated by flagging tape to follow. Any nest within 5 meters along the route is also flagged. When we come along a flagged nest from a previous week, we count the number of eggs or chicks and compare it to prior weeks. Let's watch it unfold.
Well, this one is SMHE8. Yep, small heron 8. And there are 1, 2, 3 chicks.
Exciting stuff.
Yep.
If some chicks have died or are missing, it's not the end of the world for the parents. This is natural and is supposed to happen. Typically, wading birds lay more eggs than they can raise. If something happens to some of the chicks, then there's always some backup chicks to take their place. The chicks that hatch first will be the biggest chicks. We record the chicks in each nest as chick A, B, C, and so on, with A being the biggest chick. If chick A and B survive, then as they get bigger and older, they will eventually kick out chick C and D if there is one. Now because of this, we aren't actually looking at individual chick survival rate, but more overall nest success.
Greg, 20, 2 eggs.
We're seeing which and how many nests actually have chicks that survive to fledge.
Greg, 12.
If the nest does not survive, then it's recorded as a failed nest.
Yeah, it's empty. This one failed.
Any new nest that's found is given an identification number. The species, nest stage, and number of eggs or chicks is then recorded. Once done with the transects, it's back onto the airboat to do more at a different colony. Note the throw trap on the airboat. Yes, throw trapping is done in areas of the lake here as well. And once again, it's done to get an idea of what prey is available and what the prey's concentration might be. Then, in order to see what prey the adult wading birds are actually catching and feeding their young with, we then of course do bolus sampling along the transect routes. The birds are a little more difficult to work with the older they get.
Let go of me. Okay, let's put you back.
Now might be a good time to dispel the myth about how touching baby birds will cause the parents to reject them. Well, it's just that, a myth. These birds will be just fine, and this undulation motion doesn't harm them at all. Sometimes on these unbearably hot days, we dunk the bird's bottom half in the water to help cool them off a bit.
So cute.
Also, nest height is measured from the water to see if height correlates with nest success, which is what this big measuring stick I'm carrying is for. This information can then be used to get an understanding of optimal lake water levels for nesting. Well, let's go meet back up with Marisa and Emily for the Little Blue Heron project. This time we'll start here, off the coast of Flamingo, Florida. At the southern tip of continental Florida, this is the view looking out at Florida Bay. The bay seems to be filled with an extra abundance of wildlife. If you recall, Marisa and Emily are building a habitat suitability model for little blues. While still actively throw trapping and doing foraging intensity surveys, there are still a few more pieces of information needed to build the model. One piece of information involves conducting foraging distribution surveys throughout the season, which are kind of like conducting point counts. We drive the boat along a route and stop at several points along the way. At each point, any wading bird of any species within 600 meters is counted and identified. The time, a compass bearing, and distance from the observation point is recorded to acquire locations of each bird.
Going off by itself?
Yeah, and then one great white. 500. That's probably about 600.
Doing this throughout the season helps identify favorable foraging locations, which can then be applied to the habitat suitability model.
358 degrees. Okay, that's everything.
All right.
Yeah.
Cool.
And finally, to help complete the model, a major piece of information still needed is seeing what prey the little blues are selecting and comparing it with the throw trapping data. For this to be done, we need to collect bolus samples from some chicks. With no luck so far in finding nesting little blues in the Keys, we're hoping our luck will change here in the bay. This first island is an obvious candidate. It's a hive of activity, full of many different nesting species. We stick to the perimeter. With this large of a colony, it's best not to walk on the island and disturb them. Instead, we look for flight paths of adult little blues entering and exiting the colony. And after observing for an hour, we only see juvenile little blues, which are actually white for their first year. We'll have to try our luck somewhere else. Do you see anything?
Nah, well, just a bunch of tricolors, like a ton of tricolors. And the spoonbill fledglings. It's pretty cute.
We search a few islands on foot as well, but it's clear there's no little blues nesting here either. Now, Maurice and Emily do eventually find nesting little blues in the Keys and are able to collect bull samples, but they do so after my position ends and I'm not there to film it. And when you film everything by yourself, this is how you get really sweet footage. Ugh, it's terrible. Let's get out of here. For the last research project I'll cover, I will of course end in the Everglades. And no visit to the Everglades is complete without seeing some alligators. This is the Microtopography Project, nicknamed T-Rex, for Tom's Radical Experiment. With the sun down, we can now begin the alligator night survey. The spotlight gives us a glimpse of some shimmering eyes in the darkness, which sometimes can be fleeting, just like the alligators themselves. We need to count the ones we see and estimate their size, which can be difficult with how skittish most of them are. Frogs, however, don't seem to care. During the Everglades dry down, large alligators like these ones tend to leave the shallowing Everglades and seek refuge in deeper waters, while juveniles stay behind. We're trying to locate and determine where the highest concentration of juveniles are along a transect route. Therefore, size and a GPS point is recorded for each alligator seen. Said it before, but if there's one thing you need in the Everglades, it's some good juice. I just wish I had some apple juice. The dollar store didn't have any apple juice.
Wait, they had orange juice? The dollar store?
Yeah,
How is it?
it's some pretty good juice. Now, adult alligators are known to be ecosystem engineers. When water levels recede, adult alligators dig out large depressions known as alligator holes. These holes stay filled with water during the dry season, which provide refuge for fish and crustaceans. However, juvenile alligators stay in the sloughs to avoid competition from the adults. As I stated near the beginning of this video, during the Everglades dry down, pools of concentrated prey are created, which allows wading birds to catch large amounts of prey with minimal effort. But the concentrated pools and sloughs with juvenile alligator activity have small depressions of deeper water, thus increasing prey concentration further in these depressions. Therefore, it's thought that juvenile alligators create a higher quality foraging area for wading birds. To see if this is true, first we must test whether or not juvenile alligators are creating depressions and depth variation, aka microtopography. To do this, we visit the sloughs with the highest concentration of juvenile alligators, which we found during the alligator night surveys. We measure the topography of the slough via transects to see if juvenile alligators are indeed creating microtopography. 10 and 20. These sloughs are then compared to sloughs without juvenile alligator activity, allowing us to determine if juvenile alligators correlate with the microtopography of a slough. The second thing to test is whether or not this microtopography is actually creating higher quality foraging areas. In several sloughs, we are simulating juvenile alligator activity. Depressions are dug out that best represents the average size a juvenile alligator would make. In the depression and the unaltered control area, custom fish traps are placed that stand vertical in the entire water column. By the way, if you're wondering why I'm awkwardly using the kayak in such shallow water, it's because we want to avoid walking in the slough. If we did, we could cause depressions and microtopography of our own, thus potentially skewing the data.
It's so hard right here.
The struggle. It's real, people. So, theoretically, as the slough dries down throughout the season and becomes concentrated with prey, we should consistently be catching more fish in the deeper depression areas versus the control area, showing that juvenile alligator depressions in a drying slough create higher quality foraging areas within the concentrated slough itself. That thing is way heavier than it looks, by the way. All caught prey is sorted to species, counted, and weighed, giving us the biodiversity, prey count, and total biomass for each depression and control area. And don't worry, all these fish are let go, and could potentially be caught again the following week. Well, this is where we end. The Everglades, now home to countless invasive species, is being polluted by agricultural runoff, is losing and struggling to maintain native species, and has 50% of it lost due to urban or agricultural development. It's a prime example of humans destroying an ecosystem. But the good news is that we realize our mistakes. We strive to learn and right what we have wronged. There is still plenty of beauty left here, and with CERP being the largest ecological restoration plan in history, we're fighting to keep the beauty alive. I'm Travis, and thanks for watching. I'm off now to my next research position.